Chapter 8, Section 9 in the 7th grade workbook is entitled Congruent Figures. Let's look at questions 1 and 2. The directions are the same. They're asking me to identify any congruent figures. So remember, congruent is a lot like the word equal. When we're talking about two numbers, we say two numbers are equal. When we're talking about shapes and geometry, we say things are congruent. But in essence, they mean the same thing. What they're asking me here for are shapes that are the same. So as we take a look at the American flag, or the flag rather in question 1, not American because it doesn't have 50 stars, but looks a lot like it. Otherwise, here we're supposed to name any shapes that are the same. Well, as you can see, taking a look here, we've got the smaller stripes here, and we can just go with the same colors if you want. It looks like the opposite colors are the same as well. But here, the smaller stripes all happen to look to be the same rectangles. So we're going to say that the smaller stripes here look to be the same or congruent. As we come down towards the bottom of the shape here, we've got all the longer stripes, the larger rectangles. So here we're going to say that the longer stripes also look to be congruent shapes, meaning they are the same as each other. And as we come back over here as well, we see we've got these stars, which are sided figures, and the stars are all the same there, so the stars also happen to be congruent figures. And that's all they're looking there for in questions 1 and 2. They just want to know what shapes look to be the same. Now here, in 3, 4, 5, and 6, what they're asking me for is to determine whether the triangles are congruent. They're checking to see whether the triangles are congruent by the side, side, side postulate. And what that says is we match up one set of sides on a set of triangles, a second set of sides on those same triangles, and the final sets of sides on those same triangles. If we see congruence there, that means that the triangles have to be the same. We don't even have to take the time to prove that the angles are the same. They simply are the same. So, as we look at what we've got here in question number 3, let's take a look at the side measures. Question 3, we've got a 10 and a 10 in different triangles, and we've got a 14 and a 14 in different triangles, and we've got a 22 and a 22 in different triangles. So since we've got 3 sets of congruent sides here, we're going to be able to say that yes, these triangles are congruent, simply by showing that we have sides that are the same in both sets of triangles there. As we take a look at question 4, though, we've got a couple 3's here, which is great, but they don't translate over here as 3's. They end up translating over as 4's. Since I can't prove that the sides are the same there, here we're simply going to have to say no, that these triangles are not the same. And that's all you have to do here. Try and prove that the sides match up. If they don't match up, the answer is no. If the sides do match up, the answer is yes. Use that approach in solving 5 and 6. Finally, here in 7, 8, 9, and 10, they're asking me to determine whether the unknown, or find the unknown measure or measures in each set of congruent polygons. So the pretense here is that these shapes are absolutely certainly the same because they're telling us they're congruent. So that means we know, because they are congruent, that all the sides have to match up and all the angles have to match up. That's what congruence implies. And we're supposed to find what they don't know. Well, take a look at question number 7. In question number 7 here, we're just matching up the sides. They don't give me any angle measures to work with. So look, left triangle 21, right triangle 21. We've got a match. Left triangle 34, right triangle 34. We have a match. Left triangle 52, over here no 52. Well, if I'm telling you that these are the same, there has to be a 52 over there on the other side. And since I already know the other 2's match up, that means that this missing side has to also be 52 inches. So question mark in number 7 is 52 inches, and we've shown all we need to show. As we go look at question number 9, question 9 has got a couple things looking here for. They're looking for, or rather just one, they're just looking, no, they have 2, an angle here on the left side that we're supposed to find, and a side down here on the bottom. Well, let's start with the sides, because we've already done the sides in question 7. We should be pros at this. Taking a look at number 9 here, all right, the trapezoid, we've got a 15 and a 15. We've got a 12, a couple of them, and a couple of 12s over here. Again, we'd have to because congruence says if it's on the left, it's on the right, or vice versa. And then over here we've got a 25. Well, that means this side over here that I don't have also has to be 25. So the missing side here measures 25 meters. And that shows me that the sides then of these two trapezoids are congruent. Now as far as the angle measures here, let's look at what we've got. I've got two 64s here. I've got two 64s over here. So we've taken care of those. And then as I look at this guy over here, I've got a 116 and something I don't know. But then as I come over here, I have two 116s. Well, that means I have to have two 64s in both shapes and two 116s in both shapes. Well, this one on the left, I only have one of those 116s. So that means my other angle that's missing has to be 116 degrees to show congruence. How else could we solve that? Well, we know that the four angles in any quadrilateral make 360 degrees. So take 360, subtract 64, subtract 64, subtract 116, and no surprise you'll end up with a result of 116 degrees. So either way, whether we show that there's two 116s over here, so there's two 116s over here, or whether we've used the fact that a quadrilateral makes 360 degrees, what we've been missing is 116, the missing angle over there is 116 degrees. So the angle that I'm missing is 116. The side that I'm missing is 25 meters.